Sections 2.3 and 2.4 deal with a particular type of function. We're talking about linear equations in two variables, so usually we have x and y, where x is the independent variable and y depends on what the x value is. The word linear here means that x is going to be to the first power, and if we look at the relationship between the x value and the y value, we'll see that it's a straight line relationship, okay? Your homework for 2.3 is here, and we're going to stop in the middle of the video and do that homework and then come back and do just a limited amount of homework for 2.4. Okay, so if y equals mx plus b, this is the equation of a line where x is the independent variable and y is the dependent variable because x can go anywhere in his domain. This stuff happens to it. This is your function, and for every x that you plug in, you'll get a specific y value. Now, when you collect all of the values of x and y that belong to each other, ordered pairs. Ordered means that x comes first and then y. If these values that belong to each other have to make this a true statement, and the collection of all of those points or ordered pairs is your solution to this equation here, okay? And what happens is your solution set, if you plot those ordered pairs, you'll see that they all line up and into a straight line. Okay, most of this should be review. I really hope that it is. All right, now the m in this equation is being multiplied by the x. So as x changes by 1 unit, y will change by m units. So if I go start at a point that I know and I change my x value by 1, or I move over 1 unit, my y value is going to go m units. If m is positive, I'll go up. If m is negative, I'll go down. And I'll distribute, what's the word that starts with a D? Demonstrate that in a future page here. Now, one other thing to notice, if I plug 0 in for the x value, then this bit is gone and I get y equals b. That makes b what's called the y-intercept, because if I draw the picture and I plot this point where x is 0 and y is b, I'm on the y-axis. I'm intersecting the y-axis, and that's what we call a y-intercept, okay? It's the point where x is 0, you plug it into that formula there, and you get y equals b, okay? And that point is going to be your anchor for every one of these lines. You're going to anchor yourself at the y-intercept, and then you're going to count out the slope. You're going to go over 1 unit for x and go wherever m tells you to go. Up for positive, down for negative, and you're going to go however many units m tells you to go. Now, how do you find the m? Well, for any 2 points, x1 and x1, y1, x2, y2, any 2 points that you pick that are on this line, if you find from one point to the other how far did you go in the y direction and how far did you go in the x direction, and you find that ratio, you learned it as rise over run, and this is what it represents: the change in my y value over the change in my x value. The ratio of the change in y to the change in x gives me my slope. And this is the formula. Now, if you understand what slope is, then you will never forget that formula. And it's got all these little subscripts and it's got subtraction, which always cause problems for students to get the right answer. Be very careful. Notice that one of the points is here and the other point is here. If I get my 2's and 1's mixed up, my slope will be the opposite sign of what it should be. So you've got to be super careful with that. All right, let's put this into practice. Okay, so for any line, I just did an example line here. The equation will be y equals the slope times x plus the value of the y-intercept. Notice if x is 0, y equals b. So for this particular line, that point right there represents where the x value is 0. Notice that if I don't go backwards or forwards anywhere, then I am right on the y-axis. And that value right there gives me where I cross the y-axis. That's my B, or my y-intercept. Now, from one point to the other, notice that I labeled this as point 1 and this is point 2. It doesn't matter. It's your choice which point is 1 and which one is 2. So notice that if I'm going from here to here, I had to rise this much. If I take this y value minus this y value, I get the difference in the y values. I'm going to rise this much and then I'm going to run this much. Notice to get the value of the run, I take this x value minus this x value, and it gives me the horizontal distance between the 2 points. The vertical distance over the horizontal distance, rise over run, gives me my slope. Now, so slope-intercept form, why is it called that? Because it has the slope and the y-intercept. Okay, this is the form I want you to put every single equation of every single line in, because you can look at this equation and know if it's going up or down, whether this is positive or negative. You can know if it's steep or shallow. If this is a number bigger than 1, then my slope is steep. If it's a number smaller than 1, then my rise is more than my run, and it's more shallow. If m is exactly 1, then x and y are increasing or decreasing at the same rate, which makes it a 45-degree angle. We also instantly know where we're crossing the y-axis. So I'm going to take this value of b and put my pin right there on that point, and I'm going to count my rise over my run and make a point. Notice that if I have this value over that value, rise over run, I can also say minus over minus, right? If this goes up and over, then going from here to here, I'm going to go down and back and get the same exact thing. Now, I will illustrate that in a future page. What about the x-intercept? Where do you cross the x-axis? Well, notice that where you're on the x-axis, you haven't gone up or down at all. So in this case, the y value is 0. I have an equation here. All I have to do is set that y value equal to 0, and I get the x value where I'm crossing the x-axis and get my x-intercept. So let's look at one quick example. If I have the line y equals 3x plus 2, this is in slope-intercept form, I instantly know where I'm crossing the y-axis, so I plot that point. And I instantly know that my slope is 3. Well, what is 3? 3 is, because the slope is a ratio, right? Your denominator is 1. So if my slope is 3 over 1, I put my pin at the point that I know. Don't start at the origin. Start at a point that you know is on the line. That guy right there. And I'm going to go up to 3, rises 3 over 1, and make a dot. But that is also -3 over -1, correct? So from a point I know, I can go down 2, 3, and backwards 1. Both of those are negative. Notice how those points line up. And that's how you get a line. Now, 2 points make a line, don't they? But 3 points make you sure. If the 3 points don't line up, then you've made a mistake and you can go back and correct it. Now, find the x-intercept using this equation. Look right here. Make the y equal 0. Solve for x. That's the place where you cross the x-intercept. And the x-axis, sorry. Do you see where that point is at about negative 2/3? Let me make a mark here. That point is at about minus 2/3, where I'm crossing the x-axis. Now, you and I both make crooked lines. We both screw up our scale, especially if we're doing it freehand like this one, and our pen or our pencil has width to it when we make the line. I'm telling you right now, do not use your graph to guess what your x-intercept is. Do the math. You could never figure out negative 2/3 perfectly if you were just eyeballing the graph, okay? Even if you're using graph paper and a fine point pencil and a straight edge, you're not going to get it right unless you do the math, okay? So for finding these intercepts and for finding your slopes, don't guess, do the math. Now, notice that my particular line, when x is going from the left to right, if I trace this line, my pen is going up left to right. That means that my slope is increasing. And notice that my increasing line, the slope here, is a positive number. If your slope is positive and you're tracing your function or your line left to right, you're going up. That makes it what we call increasing. So for any line, if your slope is greater than 0, that means positive, you're increasing left to right. If the slope is a negative number, then my rise goes down when my run goes to the right. So I'm decreasing left to right, okay? Now, what if it's not greater than or less than 0? What if it's exactly equal to 0? Well, that means that I have a 0 rise on the top for any kind of run on the bottom, and 0 over a number always equals 0. And for a line with no rise and all run, we have a horizontal line. And what does the graph of a horizontal line look like? Well, it's a horizontal line. What does the equation of a horizontal line look out like? Plug 0 in for your slope, and you get the equation y equals b. B is where you cross the y-axis, and b will be the y value for every single point on the line. You can stick in any x. See how this doesn't depend on the x value at all? So any x will give you y equals b. So we talked about a horizontal line, y equals b, but what about a vertical line? Well, look at this vertical line. If I take any 2 points on the line, my x values are going to be the same. In this case, I called them c. So if I use my slope formula, my x2 and x1 are the same number, which gives me 0 in the denominator, which means my slope is undefined. Vertical lines have undefined slope. Well, what does that mean for my equation? Well, look at this line. There's no dependence on the x value, right? This is all rise and no run. So all of these points are passing through the same x value no matter what the y value is, and that means that the equation of a vertical line is a formula x equals whatever the x value is of the points that you're passing through. Okay, an example of 2 points on a vertical line would be 3, negative 5, 3, positive 2, 3, 81. You get the point. All the x values are the same, and it doesn't matter what y is. You're simply passing through x equals 3. Okay, let's look at this example and try to put everything together. I have this equation. This is in what's called standard form, which is pretty much useless unless you're um, graphing using intercepts, and let's illustrate that real quick. If I take this equation right here and I plug in 0 for the x or the y, then I'm going to get the points where I'm crossing the x or the y axis. All right, so let's try this out before we move on with everything else on the page. I want to try covering up the x value, because if I make x equals 0, I'm going to get my y-intercept. So if I erase that x for a second, you see that y equals 3. Well, I'm going to plot that point on my graph right here. Okay? Now, let's put that guy back. And now I want to examine what would happen if y equals 0. Now, if y is 0, I'm going to be on the x-axis, right? So if y equals 0, just for a second, let's erase the y value. You see that x equals -3. So in that case, I'm going to plot this point right here. Well, I have this intercept and this intercept. If I connect the dots, you see my line, okay? So that's just about the only usefulness of this particular form, this standard form of an equation. What I want you to do for almost every single problem is to take this equation and put it in slope-intercept form, because that's where you're going to get the most information. So what I want to do is move the y over here and the 3 over here, and that gives me this. And this is in slope-intercept form. Y equals x plus 3. My slope is 1. My y-intercept is +3. I get that information just from looking at this equation. So if I plug in a 0 for the x, I get the y-intercept, b is 3. Okay? Now, from that equation right here, let's find my x-intercept as well. If I plug in 0 for the y, I get 0 equals x plus 3. Well, just subtract the 3 from both sides, and you get that your x-intercept, where y is 0, x is -3. That's that point right there. So we have the y-intercept here, the 3, and we have the -3 for the x-intercept. That's really all we need to know. But we also need to learn how to count out the slope to graph. If all you know is your slope and your y-intercept, then you can plot the point that you know. I'm going to zoom in on this really quickly. If I plot the point that I know, my y-intercept right here at +3, and I have rise over run as 1 over 1, then from a point I know I can count up 1 over 1 and make a dot. But +1 is also -1 over -1, so I can also go down 1 and backwards 1 and make a dot. Those 3 points will make my line. 2 points make a line, 3 make you sure, and then if you also have the x-intercept, you see how perfectly these guys line up and create your picture of the relationship between your x and y values in this particular equation. So I want you to practice doing all of these things for all of the problems. Okay, next example. We have this equation. Now I can do the same thing. I can make this piece 0 and divide the 2 and get y equals 2. So I know my y-intercept is going to be at +2. If I make this a 0 and divide by the 3, I get the x-intercept is +4/3. A fraction's not as easy to graph. That's why we want to find our y-intercept first and count out the slope. Okay? So here we go. I'm going to take that equation and solve for y. So I'm going to subtract the 3x and divide everybody by 2, but I'm dividing every single term by 2. So the -3x is divided by 2, and the +4 gets divided by 2. There's my slope, the number in front of the x. There's my y-intercept, positive 2. So to graph my line, I'm going to plot my point at y equals 2, and from that point, I'm going to go down 1, 2, 3, and over 2 and make a point. I went down and over to the right, but my m also equals positive 3 over negative 2. Remember, 2 points make a line, but 3 points make you sure. So from the point that I started with, the point I know is on my graph, I can also go up 2, 3, and backwards 2. Okay? Let me put the tick marks on my axis here so we can see. I went over one there, and there, and over here. Okay, so now I have 3 points counted out by slope from the point that I knew, and I can connect these dots, and I have my line. Now, let me show you something. You look at this right here. It looks like I'm crossing the x-axis at 1. Do you think that's true? I don't know. We're going to have to check it with the math. Zoom in on that. Can't really tell, right? I'm telling you, you're not going to be able to find these things just from eyeballing it. Okay? You got to do the math. So I know my slope, I know my y-intercept, I found 2 more points on my graph, and I connected the dots, and I have graphed it. But just for good measure, let's find the x-intercept. Y equals 0 gives me 0 equals minus 3/2 x plus 2. Move the 3/2 x to the left. Multiply both sides by 2. You can do this in one step by multiplying by 2 over 3. But just to make sure that you know what you're doing, I'm going to eliminate the denominator first. Multiplying by reciprocal is just doing what I'm doing right now. I get 3x equals 4, and I get my x equals 4/3. So that's not exactly 1. It's 1 1/3. So my x-intercept, when x is 4/3, y is 0. Okay? So notice that that's 5 pieces of information. I gave you an equation. You got the slope. You got the y-intercept, you got the equation in slope-intercept form, you got the x-intercept, and you graphed it. Those are the 5 things I'll be looking for. Next example. Given a slope and a y-intercept, can you find the equation? Well, that should be pretty easy because y equals mx plus b means that y equals minus 1/2 times the x plus b is minus 2. Okay? Now I took up all the space for the graph, so I'm going to zoom in. Sorry about that. I'm going to zoom in and put my graph right here. All right? I know that I have a point at negative 2, and I'm going to go down 1 and over 2 and make a point. Or that minus could be on the bottom, and my rise could be up and run b backwards. Notice that my line right now, left to right, is going down. That means that my slope is negative. My line is decreasing. All right? Now, very small over here, if y equals 0, what is my x-intercept? Multiply both sides by 2. I'm going to cross the x-axis at -4. Does that look right on my graph? Well, 1, 2, 3. I fudged a little. We're going to make that point really big so that it crosses at the right spot. You do that in blue. All right. Your graphs are never going to be perfect. My axes are crooked. My scale is off. Even with graph paper, you can't eyeball it. You have to do the math. All right. So that's a lot of stuff. And there's more. So let's get to it. Okay, for the line that passes through these 2 points, I want you to find all 5 of these pieces of information. Okay? Now, given this situation, let's talk strategy. If you have 2 points, then you have the line already. The graph should be the first thing that you do. When you're finding your slope, you can look at the graph and know if your slope is positive or negative. You can even count your rise and count your run. It's the same as using the formula, but making sure that you understand what slope is and you're thinking critically is going to be essential. All of this information has to work together and make sense. So I'm going to do my best with my scale here. So point number 1 is that x is -1 and y is at 3. Both at the same time, right? Point number 2, x is 2 and y is up at 5. That makes a point right there. I'm going to connect the dots with as fine a line as I possibly can. And I'm telling you right now, you cannot find your x and y intercepts by looking at that graph, okay? Don't even attempt it. You got to do the math. Now, what can I find out with just having 2 points? Okay, I'll tell you. You can find out every stinking thing, okay? Let's look at this. If I went from y equals 3 to y equals 5, what was my rise? I went up. By the way, my slope is positive, right? I went up 2 units. When I go from -1 to +2, what's my run? I went 3 units, and my slope is positive. Watch this. M equals the ratio of the starting from this point right here, y was 5, and I went down to y was 3. Starting with this point right here, my x value was 2, my other x value was minus a -1, which makes that +1, right? Look at my slope, 2 on top, 3 on the bottom. And that was my rise over my run. So I could have just written down the answer once I plotted the points and counted. M equals 2/3 positive slope. All right. Now, finding the y-intercept, I can tell you right now, it's not a whole number, it's a fraction. So finding the y-intercept should not come from looking at the graph. I have to do the math. And you know what's easier than finding the y-intercept? Finding the equation. Now I want to show you something very quickly that I explain a little bit more on the next page. We actually derive this formula, but here in red I want to write the point slope form. Y minus the y value of a point equals the slope times x minus the x value of one of the points. Now, again, you get to choose which point is 1 and 2. All right, look at this slope over here. What if I had started with the other point? What if I had started with this? that y value was positive 3, and I subtract the other y value, which was 5, and then I have to start with the x value of my first point. X was negative 1, and the other x value was 2. Look, that gives me negative 2 over negative 3, which is just 2/3. So you get the same slope no matter which point you start with. You just have to always be careful that this is one of the points and this is the other point. This is one of the points, this is the other point. All right? And remember, it's always the change, so you're always finding the difference. This is always subtraction. Now, I'll show you on the next page how to derive the point slope form, but what you need to pay attention to when you're using it, notice that this x has no little subscript and this y doesn't have a subscript. These guys are just x and y, whereas this is the y value of one of the points and this is the x value of the same point. Slope, I already have to know that to do this problem. So y minus, I can pick a point. I'm going to use this point because they're both positive and minus signs mess me up. So y minus the y value equals the slope that I found times x minus the x value of the same point. So if I used y equals 5, I have to use x equals 2. If I mix up my points, everything is wrong. Okay? Now, solving this equation and putting it in slope-intercept form is going to be the best thing that I can do because it gives me a lot of information. So I'm going to distribute the 2/3 to the x, that's mx, and then minus 2 times 2/3 is 4/3. Now I have to isolate the y, so I get 2/3 x minus 4/3 that was there, and now I'm going to add 5. Well, I have to get a common denominator of 3 so that I can put my numbers together. That gives me 15 on the top and 3 on the bottom, and I get my equation y equals 2/3 x minus 4/3 plus 15/3 is plus 11/3. That's my equation. I'm sorry, this keeps moving around here. Fat hand here. So my equation in slope-intercept form is y equals 2/3 x plus 11/3. From that equation, if you plug in a 0 for the x, you get your y-intercept is 11/3. So what I have now, m is 2/3, b is 11/3, y equals mx plus b, so the plus b is plus 11/3. That's my y-intercept. See how it all works together? Now, does that make sense on my graph? 11/3. Well, let's see. 1 is 3/3, 6/3, 3 is 9/3, 12/3, and you see that I crossed just above 9/3 before I got to 12/3. Let's zoom in here so we can see. You're always going to be off a little bit, but there is my y-intercept at 11/3, which is 3 2/3. So the point is, when I found my y-intercept, I could look at the graph and know that my graph was correct and my y-intercept was correct. What if I had accidentally gotten negative 1/3 when I did this math right here? My y-intercept can't be down here. because I have these 2 points. So I can check my work and I'll never get anything wrong because I know everything has to be working together to make it all perfect. So for the x-intercept, I'm going to plug in 0 for the y, 2/3 x plus 11/3. Move this guy over. I'm going to multiply by 3 and divide by -2. So I see that my x-intercept is negative, and it's a fraction. That's a pretty big number. So my x-intercept, when x is minus 11 halves, I said thirds earlier, y is 0. All right, does that make sense? Well, let's zoom in a little. Negative 11/3, 2, 3, 4, 5, 11 halves. I keep saying the same thing. This is, let me get my pointer. 2 halves, 4, 6, 8, 10, 12, and you see that we have our point right there at negative 11/3, lined up pretty nicely. All right, so everything works together, it all agrees, and that's how I know that I did my problem correctly. Okay, the point slope form that we just used right here. Remember that x1, y1 is one of your points, m is your slope, thus point slope form, okay? So we have, that line shouldn't be there, hold the phone. We have the point x1, y1. Have no idea why I put a line instead of a comma. Here we go. Notice that your slope formula is this, right? You see that x1, y1 right there? Now, for the equation of a line, it has to be true for any point on the line, right? For y equals mx plus b, I can plug in any point for the x and the y value and get a true statement. Well, it's the same thing with the slope, right? I can plug in any 2 points, x1, y1, x2, y2, and get a true statement for that line, okay? Which means that I can pick any arbitrary point that lies on the line. So I can say for any point x, y, this thing has to be true. So watch what I do. I take one of these points and make it the generic point x, y. That gives me this formula for the slope. Now take that formula and multiply both sides by the denominator to clear your fraction. Do this, and you get this equation, which is your point slope form. So the point slope form just comes from the formula for the slope, but it's true for any point x, y on the line. All you need to know is the slope and one of the points. Okay, one more example here. We've got the point 2 minus 3. Remember, if you're given points, you want to plot them and connect the dots and get the graphing done. Minus 2, 3, up 1, 2, 3, 4, 5. Guaranteed to not be perfect. See, I already put that point a little too high. All right. Now, if I had a straight edge, I could connect the dots and get my line. Is my slope going to be positive or negative? I may have to correct my graph here. Notice that from left to right I'm going down, so my slope will be negative. I already know that. Okay? Now, when I go from one point to the other, and it doesn't matter which way I go, I'm going to rise from -3 to +5. What rise is that? It's a rise of 8 units. And I'm going to run, everything's crooked, sorry. I'm going to run from +2 back to -3. What is that run? 2 units on one side and 3 units on the other. That was a +5 on that axis. Sorry. So 2 and 3 is a run of 5. And notice that it's negative. I already figured that out from looking at the paper or at the graph. So my rise is 8 and my run is 5. All right? If you want to do the math, m equals, pick a point to start with, -3 minus 5, 2 minus a -3. M equals -8 on top, +5 on the bottom. And if you switch those points around and you start with this point, you're going to get the negative on the bottom and a positive on the top. Same answer. All right, like we did before, we're going to go, we have a slope and we have 2 points, so we can use the point slope form, right? And I recommend that you do that, but I do want to show you something really quickly. Y equals mx plus b is true for every single point on the line, right? This is a little cheater way of doing this that a student showed me that never occurred to me, and it's my preferred way to do it now. I can pick either one of these points. I'm going to choose this guy. And this point, my y value is -3 and my x value is 2. So my y value is -3. My slope is -8/5. My x value is 2 plus b. Notice that the only thing that I have to figure out now is b. So if you use the point slope form, you get the equation of the line. If you use the slope intercept form, you get the intercept. So you can do whichever thing that you want to do. B equals 1/5. That looks good on my graph, right? My graph looks like it's crossing at the origin, but it's actually just a little bit above. This is the point where x equals 0, right? And now because I know my m and I know my b, y equals mx plus b. And I have the equation of the line. Now, just for good measure, because I know I just made some of you uncomfortable, we're going to use the point slope form, which is y minus y1 equals m times x minus x1. Did you notice how awful this was with the minus signs and the fractions? Yeah, even more awful. So here we go. I'm going to plug in one of the y values. Notice that when I did this one, I used x is 2, y is -3. It doesn't matter which point you use, you're going to get the same answer. So let's mix it up and use the other point for what we're doing now. So I'm going to use -3, 5. So y is 5. My slope is -8/5. X minus the x value that goes with 5 is -3. So when I subtract a negative, I'm adding. So y minus 5 equals -8/5 x. There's mx. And then -8/5 times 3 is -24/5. Y equals -8/5 x minus 24/5, that was there, plus 5. Common denominator, I have to multiply, hold on, let me change my color. I have to multiply this by 5 over 5 to get the common denominator. That means my numerator is 25. I get y equals minus 8/5 x minus 24/5 plus 25/5 gives me plus 1/5. And there is the equation. So when you use the point slope form, you get the equation in slope intercept. From that equation, you get your y-intercept. If you start with the slope intercept form and you plug in your slope and you plug in one of the points, you're going to solve for your y-intercept. When you get the y-intercept, you plug in the m and the b and you get your equation. So with this, you get the equation. With this, you get the intercept. You either use the intercept to get the equation or you use the equation to get the intercept, and it's all your choice. I found that this, because of the minus signs and the fractions, was a little bit easier than this because this has all the subscripts and the minus signs, and you're plugging in the fractions. You're still doing the same common denominator process here, right? It's the same kind of thing. You're adding a different number, but it's still the same difficulty level. So it's all your choice. Go for it. Now, the x-intercept is where we plug in 0 for y. 0 equals minus 8/5 x plus 1/5. 8/5 x equals 1/5. Multiply away the 5, and you get 8x equals 1, and you get x equals 1/8. So that gives me the value of y of x where y equals 0. And you get your x-intercept. Now, the y-intercept was at 1/5, a little bit above, and the x-intercept is at 1/8, and I'm going to go for it. I think I did a pretty decent job there. You're never going to be perfect, so you got to do the math. You need to stop now and do the homework from 2.3. It looks like a lot, but it's really important that you get this stuff down. And then come back to this video. We've got 2 other quick things to talk about. 2.4 is all about parallel and perpendicular lines. Your homework for 2.4 is 5 through 11 odd. That's only 4 problems. Pretty straightforward and simple. You will have to use all of your skills that you got from doing the homework for 2.3. So if you haven't done that yet, you need to go back and do it now. Okay? All right, parallel lines have the exact same slope, right? They never cross each other either because they're always rising and running at the same rate. Perpendicular lines, when you think about lines that are at a right angle to each other, if one line is, hold the phone. If one of your lines is increasing and you have a perpendicular line to that, it has to be decreasing. No matter where you turn, because the angle between those 2 lines is 90 degrees, if one's positive, the other one's negative. So if one is increasing, the other one is decreasing. That means that your perpendicular lines are going to have negative slopes from each other, opposite signs. But also, if this line and this line, they're related by the rise becomes the run and the run becomes the rise. It's like if you think about the x and y axis, they're perpendicular to each other, right? Whereas this is run and this is rise. When you flip them over, you get the flipping of the rising and the running, all of that to say that the slopes are upside down of each other. You're gonna flip-flop the rise and run and change the sign for the slopes. Okay, so if you have a line with a slope minus 2/3, all parallel lines will have the same slope. All perpendicular lines will have the opposite sign and flip it upside down. Find the reciprocal. Okay, now parallel lines can be your y-intercept is going to change, right? If I give you a point that a line is going to pass through, you're going to find the slope of the parallel line. In other words, you keep the same slope, and you're going to do what you did in 2.3 and pass through a point that I give you. If it's perpendicular, you're going to find the slope of the original line, and you're going to pass through that new point using your new slope. Okay, given the equation of a line, you want to find the equation of a line parallel to it through a different point. What I want you to understand is wherever this line is on a graph, I don't care. All I want to know is what is the slope of this line because I'm going to pass through this point. All right? So we're going to use this line, put it in slope-intercept form to steal his slope, and then we're going to blow him off. We don't care about where he is. We don't care about the b value. We only care about the m. Then we're going to make a new line that passes through that point. All right? So the process of finding my slope is just solving for the y value, and I just missed a minus sign. So I'm going to move the x term to the other side and divide away the 5. I get minus 2/5 x, and I don't care about the rest of that because it's the slope that I need, not the y-intercept. So for my new line, my slope, if I'm parallel, is 2/5. If I had said perpendicular, you would flip that over and make it positive, right? So on my new line, it has that slope through this point, okay? Now, I showed you two different ways to do these. You can use the point slope form, or you can use the slope intercept form to get your intercept. I'm going to do the point slope form so that my colleagues won't get pissed off at me. Good? All right, so y minus the y value of the point equals the slope times the x minus the x value is -1. Y minus 3 equals minus 2/5 x, there's your mx, minus 2/5 times 1, and now I have to add 3 to both sides. Y equals minus 2/5 x minus 2/5 plus 3. Got it? 3 is 15/5, and I get the equation of the line minus 2/5 plus 13/5. There's the equation of my new line. Notice that I don't care where my original line crossed the y-axis. I'm not going to graph him. I don't care about him. I'm just going to use him to get his slope and then leave him in the dust. All right? Let's do the next one. I want the equation of the line that's perpendicular to this given line. So I'm going to start with the original line and move the y out of the way and move the 4 back. All I did was move things. I moved the y over here and got rid of the 4. And now I'm going to divide everybody. Oh, I'm done, aren't I? All I care about is his slope. Well, that was a little too easy. His slope is +3. So what is my slope? My slope is the opposite sign and flip that 3 to the denominator. This slope over here was +3/1. I make it negative 1 over 3. And I'm going through the point 2 minus 3. Okay? So y minus the y value, y minus negative 3 is y plus 3 equals the slope times x minus the x value of the point. Distribute y plus 3 equals minus 1/3 x, there's mx, plus 2 times 1/3 is 2/3. Y equals minus 1/3 x plus the 2/3 that was there. And now I'm going to subtract 3 from both sides. 3 times 3 is 9. And I get the equation of the line. 2 minus 9 is minus 7. Notice that I didn't care about the y-intercept of the line that I started with. I only care about the line with the perpendicular slope that passes through this point. Okay? Now you should be able to do all of the homework, all 4 problems from 2.4.